Okay, we are now going to talk about vector addition, about adding vectors. And so in this example here, I have, we're going to suppose that a car is driving 5 miles from point A to point B, and then it drives 3 miles from 3 miles to point C. So let's just assume, first of all, that when it drives from point A to B here, it's actually going exactly east. Okay, so B is east of A. And then when it drives 3 miles to point C, C is directly north here of A. And it drives 3 miles. And we'll say that is C. Okay, so its trip from A to B is like one vector, and we could call that, vector U. And its trip from B to C, that's another vector. We could call that vector V. And so to add these two vectors, to add U and V together, is to get the vector for point C. So from A to C. So instead of going from A to B and then B to C, when we add U and V together, we're going to go from A to C. Like this. And this vector would be U plus V. And that's the idea of adding vectors. And we'll actually do this here in a second, but let me generalize this now just to two different vectors, okay? So let's say, we'll say here's point A and point B, like that. And that's 5 miles from A to B. And that's U. And then we can say that C is like over here, right? Okay. Same idea. This is one vector. This is one vector. Okay. This is the other vector. The addition of U plus V would be the distance from the beginning A to the end, C. And so this would be your U plus V. So what we do here, we can do in general over here. Okay? So now, let's see if we can actually find vector A to C. Let's see if we can find the length and the magnitude of, or not the length and the magnitude, those are the same things. But let's see if we can find the magnitude and the direction. Okay, so the way to do this is like a right triangle. Okay, and I can put like magnitude of U is 5, and the magnitude of V is 3. And so finding the magnitude of this vector is easy because that is the Pythagorean Theorem, right? So we would have like the magnitude of U plus V, that quantity squared, is equal to 5 squared plus 3 squared. And so this would be, I'm going to just write this again. U plus V, that quantity squared. So this would be 25 plus 9, which is 34. And then take the square root of both sides. So I got U plus V. The magnitude is the square root of 34. So I'm just using the Pythagorean theorem to find that side of the triangle. Okay, so then if I wanted the direction, so we'll just say the direction from the east going up here like that. So that means what I want to do to find the direction, I want to find this angle. So I know that the tangent of theta is going to be the opposite over adjacent, so 3 over 5. So my theta is going to equal tangent inverse of 3 over 5. And I'm going to use this here. I'm actually charging the other calculator at the moment, so it's probably charged. I could probably go over and get it, but I'll just go ahead and use this. It can do inverse tangent. And so it looks like it's 30.96, so approximately we'll just say 40 degrees. If I round to the nearest degree. Okay, so there's the magnitude and there's the direction. And this would be the magnitude and the direction of the resultant angle. So we call the sum of two angles, u plus v, the resultant angle. Okay? So, what about this one though? Okay? This one's a little more tricky, isn't it? So we know that this magnitude is 5, and we know that this magnitude is 3. You're going to have to know an angle. So let's say we know that when I turned, that this angle, we'll say, was 115 degrees. 115 degrees. Okay? So, how would we go about finding this angle? I know this side, and I know the interior, the angle that makes up those two sides here. And I'll zoom in. Okay, so you got a triangle. Okay, but this time it's not a right triangle. Is there something if I have a side angle side? So I can use the law of cosines, right? So this u plus v, and let me just call that c here just to make things easy. C squared is just equal to 5 squared plus 3 squared minus 2 times 5 times 3 times the cosine of 115 degrees. So c squared is equal to, this would be 25 plus 9 minus 2 times 5 times 3 times cosine of 115 degrees. And I get like, this whole thing was like 46.6785, so on. And then to get this actual side, I got to take the square root of this side over here. Okay, so I'm going to take the square root of the answer, and it looks like I get approximately 6.8. We'll round to the nearest tenth. 6.8. So this is actually the magnitude of the vector, right? This is the magnitude of u plus v. Okay? So is there any way then that I can find the angle of this direction? So let's see here. If this is east, see, we don't know that. I'm thinking because this thing could be positioned however, that what you can find is you can find this angle here. So what you're going to do is you're going to find the distance that it is from this angle. You're going to find the angle that this is from this angle right here. And what you could do is you could use the law of sines to do that. Okay? We would have the sine, we'll call that theta. The sine of theta is to 3 as the sine of 115 degrees is to 6.8. So I get the sine of theta is equal to sine of 115 degrees over 6.8. Times 3. Oops, sorry, times 3. And this is going to be, so sine of 115 divided by 6.8 times 3, and so I get like 0.39984. I'll just write that, and now this is like a trig equation, right? So my theta is going to be the sine inverse of 0.39984. And so I'm going to do sine inverse of the answer, and I get 23.6 degrees if I round to the tenths place. Okay, and that is going to be the angle that it makes, that the resultant angle makes with this vector right here. Okay, and so that's how these problems are usually given. It's given as two vectors and the angle between them, the magnitude, the angle between them, and then what you want to do is you would like to find the magnitude of the resultant vector and the angle with respect to one of the two vectors. Okay, so let's try one more. Oh no, wait. We're gonna leave it right there for that. That's the addition of two vectors. And in the next video, we are going to talk about another way of thinking about the addition. They call it the Parallelogram Law, and it will show us that vector addition is commutative, and then we'll actually use that to add two vectors together.